Hello everybody. This video is going to be about how your central nervous system codes for perceptual events and even some cognitive events like memories. Now, let's start off with talking about what do I mean by coding. Well, remember that your nervous system is composed of neurons, and so although it's far more complex than this, you can kind of think of each neuron like a binary distinction. So what I mean by that is you can think of each neuron as a 1 or a 0. Okay, and so it either fires 1 or it doesn't, 0. Again, it's far more complicated than that, but I'm trying to put this in simple terms. Now, and hopefully stating it that way will make this a little bit easier. So then the question becomes, if we have a perceptual event like a person, right? So we see their face, all right? Well, seeing their face is a perceptual event. So like Willie right here, okay? So we see their face, that's a perceptual event. Well, how do our neurons, which again, you can think of in a loose way as being binary, 0, 1, how do our neurons, or what pattern of activity across our neurons represent that perceptual event, the perceptual event of Willie Nelson? Well, depending on where you're talking about, the brain represents different things, different perceptual events in different ways. All right, so for example, there's a little bit of evidence for specificity coding. Specifically, this is when you have one neuron, when it becomes active in the presence of a specific perceptual event. All right, this is akin to the idea of a grandmother cell, a cell that becomes active when you encounter this perceptual event. Now, there's some evidence of that or something like that when it comes to concepts. So, for example, Goldstein's book talks about Halle Berry, right? So Halle Berry, yes, is a person, but she's also a concept, all right? So you know who Halle Berry is from me saying her name. You would know who Halle Berry, I'm following. You would know who Halle Berry is from seeing a picture of her. You might even think of Halle Berry seeing Catwoman, all right? Unless you tried to shove that movie from your memory, all right? The point is that all of these things have been shown to activate, there's evidence that all of these things can activate a single cell. Now, that not everybody's going to have the same concept cells as everybody else. It largely depends on what concepts you've encountered. But the point is that with there's this evidence of specificity coding, or the idea that one neuron can process one concept. And so, you know, if we were to represent it visually using Goldstein's images, let me share the screen. Right? Okay. So if we were using specificity coding, right, then if we saw Bill, right, of all these cells, only cell 4 becomes active. You know, whereas with Mary, of all these cells, only cell 9 becomes active. And so only one cell specifically is coding for Mary. One cell is coding for Bill. One cell is coding for Raphael there. Cool name, by the way. So, specificity coding is when you have one cell coding for one concept, or at least for one perceptual event. And again, the best evidence we have for specificity coding is with concepts. And these concept cells are usually somewhere in the inferotemporal cortex, which shouldn't be all that surprising considering the fact that the areas that we use to recognize objects is largely in the inferotemporal cortex. All right. Well, specificity coding isn't the only way our central nervous system may code for things. Other aspects of perceptual events may be coded across a wide range of cells, meaning your perception of, let's say, well, we'll stick with Willie here. Instead of talking about the concept of Willie, we're talking about the perception of his specific face. All right. Well, there's a lot of different details in his face. You got the bandana there, you got the hair, you got the beard there. I mean, there's a lot of different details, and so there's a lot of basic perceptual features to his face. And so each of those features and each small feature may have a neuron dedicated to it. All right, and so the full representation of Willie's face here may be spread across multiple neurons or a large population of neurons. And that gives us a different kind of coding pattern known as distributed coding. So if we're talking about the actual details of Bill's face here, or Mary's face, or Raphael's face, right, we see that the pattern across these 10 neurons is distributed. So it's not a matter of 4 being Bill or 9 being Mary as it was before. Now we're talking about this pattern of firing across 10. So you get, moderate to moderate firing in cells 1, 5, and 9, and middling in 7 and 10, etc. Whereas this pattern of firing across all 10 of these cells is not the same for Mary or for Raphael. And so the pattern of firing across these cells changes. And so you can think of these kind of like a neural signature, right? So a neural signature that requires requires a wide population of cells to code for. All right, so this is probably closer to what is actually happening, at least with the perceptual event. Not necessarily the coding event, but certainly probably the perceptual event. Now, we don't necessarily need all of the cells in a perceptual system to code for everything we might ever perceive. So, you only need a small subset of cells to code for Willie's face. You only need a small subset of cells in your occipital cortex to code for my face. You only need a certain subset of cells to code for your best friend's face. All right, and so instead of requiring the entire population of cells to code for each perceptual event, sometimes you only necessarily need a small subset of your population of cells to vary in the coding. So that neural signature that we talked about, that with distributed coding is distributed across all the full population of cells. With sparse coding, you only need a small or a sparse number of that population to adequately code for different perceptual events. And so that's what we call sparse coding. All right, so again, you're only using a small number of the cells to code for each perceptual event. So let's go back to our example here, right? So now you notice that if we look at the pattern of firing for Bill, you notice that not every cell, not all of the 10 cells are actually being used. Only 2, 3, 4, and 7 are. And with Mary, only 4, 6, and 7 are. And with Raphael down here, only 1, 2, and 4 are. And so the neural signature, the pattern of firing that represents Bill here, is only spread across 2, 4, and 7. It's not spread across all 10. The neural pattern of firing for Mary here is only spread across 4, 6, and 7. It's not spread across all 10. So it's on the pattern of neural firing necessary to represent Bill, the pattern of neural firing necessary to represent Mary, to represent Raphael, is spread across neurons like it is with distributed coding. Here. Oh, there we go. Yep. All right. So it's spread across multiple neurons like it is in distributed coding, but with distributed coding, it's spread across the entire population of cells, whereas with sparse coding, it's only distributed across a small number, a sparse number of the cells in that population. And that, my friends, is the different kinds of coding patterns. All right, so you got specificity coding, where you only have one cell coding for one perceptual stimulus, like Bill, Mary, or Raphael. Distributed coding, in which you have an entire population of cells, and each one of them has a specific pattern of activity, and the pattern of activity across all cells in that population represent a person or some perceptual event, like seeing Bill, Mary, or Raphael's face. That's distributed coding because it's distributed across the entire population. The code for Bill, Mary, and Raphael's face is distributed across the entire population. And then you have sparse coding, which it's basically a small version of distributed coding. It's just distributed across a sparse number of cells in the population. Okay. All right. There you go. That is your brief coverage of the different types of coding in which the central nervous system, the cells, and the neurons in your central nervous system may use to code for the different perceptual events you experience and certain cognitive things like recognition or memory. All right, guys. Geese. Apparently, I'm talking to geese. No. All right, guys. That's it for this video. If you have any questions, as always, please send them my way. If not, take it easy.